Hello, grade 8. Are you fine today? Let's complete our first lesson, which is talking about the states of matter and their properties. We stopped at the factors which affect the speed of diffusion, right? We said we have 3 states of matter, which are solid, liquids, and gases. We said that we compare between of these 3 states of matter according to the fluidity, compressibility, and diffusion, right? We stopped at the factors which affect the speed of diffusion. We said we have 2 factors affect the speed of diffusion, which are temperature and the mass, temperature and the mass of molecules. First we said when we put a packet of tea inside hot water, the molecules of tea spread quickly inside hot water, while in the cup which contains cold water, the particles of tea take longer time to spread inside the cold water, right? So by increasing the temperature of the medium, the velocity or the speed of diffusion inside it increases also. So there is a direct relation between the temperature and the speed of diffusion. Increase, increase, decrease, decrease. The second factor is the mass of molecules. When I draw here larger molecules, do you observe what happened? The liquid inside can't spread well, takes longer time to spread between these molecules. Why? Because there are tiny spaces between of them. And by increasing the size and the mass of molecules, the speed of diffusion decreases. So there is an inverse relation between the mass of molecules and the speed of diffusion. So its relation is directly with the temperature and inversely with the mass of molecules. I'm talking about the speed of diffusion. But today also, I'll ask you some give reason questions. You have to answer correctly about each of them. First, when I talk about solid matter, first question is, we want to conclude some theory is very important. To conclude this theory, you have to answer these give reason questions. First, give reason. Solids are not fluids. They don't have the fluidity property. They don't take the shape of their containers. The answer must be related to the attraction force between solids molecules. The answer is because the attraction force between solid molecules is very strong. So they are not fluids. They cannot flow easily. They cannot flow anymore. But when I ask you, solids are incompressible matters. Why? The answer must be related to the interparticle spaces between of them. So we have to say because the interparticle spaces between the solid molecules are very small. When I ask you, give reason. The diffusion through solids is very slow. Why? Because of its movement. The molecules of solids vibrate in fixed positions, tiny movement, vibration motion, so they cannot flow easily. The same questions I have to ask about liquids. You have to answer by the same way. When I ask you about the fluidity of liquids, Why liquids are fluids? They have fluidity property. They take the shape of their container. The answer must be the attraction force between its particles, which is relatively weak. Okay, when I talk about the compressibility, give reason. Liquids are incompressible. Liquids are incompressible. Because, yes, because of its interparticle spaces, which are relatively large. Okay. When I ask you about the diffusion of liquids or diffusion of matters inside the liquids, which is average or moderate, it's related to the motion of particles because the particles of liquids move more free. The same questions about gases. When I ask you, gases are fluids. They have the fluidity property. It's related to the attraction force, which is very weak, yes, between its molecules. When I ask you about the compressibility, gases only are compressible. Why? Due to the interparticle spaces, which are very large, so they can be compressed easily against solids and liquids because there are smaller interparticle spaces between their molecules. So we can't compress them because there are tiny spaces already between them. But gases, no. Gases only are compressible matters due to the interparticle spaces between them, which are very large. When I ask you about the speed of diffusion of matters inside gases, you have to say, wow, it's very fast, as I did before by using a perfume in the previous video. Do you remember? You have to answer because gases move randomly with completely free motion. Okay, through these give reason questions, we can conclude the most important theory which is called the particle theory of matter. What is the particle theory of matter? This theory is talking about the behavior of molecules of any atom. First, this theory says what? Molecules are invisible. As we know, we can see molecules under microscopes, right? So they are invisible by our naked eyes. What else? These particles always in continuous motion. They are similar in the same matter, so the molecules of this big are similar, while they are different than the molecules of this bottle. Okay, so they are similar in the same matter, but different in different matters. Third idea of this theory says what? All molecules have potential energy. Give reason. Due to the attraction force between their molecules. Yes, the attraction force between their molecules make them more stable, without more motion. So that increases the attraction force, that increases the potential energy. But also these molecules in motion state. So also these molecules have kinetic energy, but differs from what? Differs from state to another. As we know, they are maximum in gaseous state, decreases in liquids, and decreases again in solids. Yes. Okay. This theory says what? It's called what? The particle theory of matter. The particle theory of matter. the theory, we want to describe the motion of molecules. To describe the motion of molecules, you have to do this experiment with me, to imagine with me how do molecules move inside any matter. Okay, I have a balloon. This balloon has pieces of paper inside. Observe. Wow, did you observe what happened? Again? Did you see how did the molecules move? They collide each other's inside, as you saw. The molecules inside collide each other's. So, this motion of molecules inside the balloon or any matter is called Brownian motion. It's called Brownian motion. What is Brownian motion? I mean, as you saw, the random motion of relatively large particles when these particles collide each others in all directions. As you saw inside the balloon, the particles collide each others and move randomly, okay, inside all the balloon, all direction of the balloon. Okay, this motion is called the Brownian motion. Why we say it's a Brownian motion? It's related to the scientist Robert Brown, who discovered the random motion of molecules inside the matter. So, who discovered the random motion or Brownian motion? Related to its name, the scientist Robert Brown. Okay? We discovered the movement of molecules inside the matter. Now we can ask other give reason questions. When I ask you, difficulty of breaking a piece of rock, I can't break down this pig or this piece of food or this piece of rock very easily. It needs more tools. It needs more effort. Why? It's related to two things: the attraction force between its molecules and the interparticle spaces between them. So I have to say, because the attraction force between its molecules is very strong, while the interparticle spaces between them are very tiny or very small. The same in liquids, but different question. Dissolving of table salt in water. When I put an amount of sugar or salt inside a cup of water or a cup of tea, they dissolve easily. They are soluble. They are soluble in water. Do you think why? Because the attraction force between the liquid molecules is relatively weak, while the interparticle spaces between them is what is relatively large. The same in gases. Its attraction force is what is very weak. So the diffusion of candle smoke is with very high speed inside the room or anywhere. We can smell any other, as I said in the previous video, also is related to the interparticle spaces between them, which are very, very large. Okay. Now we have something seems strange for you. Are you ready? We said we have 3 states of matter, as I said from the first video, right? Okay. How many states of matter? We said 3. First, the solid molecules in solid state. As you see, molecules are very attached together. This is called solid state. When solid state gains thermal energy, what happened? The molecules go away and get spaces between them. The spaces or interparticle spaces between the molecules, what happened? Become larger. When this is called what? Liquid state. This is called liquid state. When liquid matter gains more thermal energy, what happened? It changes into gaseous state. Changes into what? Gaseous state. So the interparticle spaces become more and more, and the attraction force between its particles decreases, right? Okay. Did you remember before, or did you think before, what happens if the gaseous molecules gain more thermal energy with high temperature, with thousands and millions of temperature? Oh, what will happen if gaseous matter gain more thermal energy? It will change into the fourth state, which is called plasma state. It's a highly energetic state. What happened? When these molecules gain heat, as we know from grade 7, the atom has in the center a nucleus, right? I can draw it again. In the center of the atom, there is a nucleus. This nucleus has positive protons and neutral neutrons. Do you remember this? Okay. Outside the nucleus, we have energy levels. These energy levels contain electrons, I mean negative charges of electrons. When this atom gains more thermal energy, the electrons leave the energy levels and become free. So now we have free positive charges with free negative electrons together. I can say now the atom is ionized. What is meant by ionized or highly energetic state? As you see, I mean this atom gained a high amount of temperature. Highly energetic state is known as plasma, that make the electrons more free and surrounded the positive protons. So now we have mixture of positive protons or positive ions with negative electric ions or negative electrons. Okay, this highly energetic state is known as plasma. Yes. So we can say, what is plasma state? It is the fourth state of matter in which the gas becomes a mixture, as I draw, between positively charged protons and negatively charged free electrons. Okay, and this is the fourth state of matter. Do you know that, as you see here, these were the gaseous atom? After ionization, they become positive charged ions with negative electrons together, mixture of them, that's called plasma state. At which time we can see plasma state? Do you know that most of space be in plasma state? Yeah. Like what? Most of matter in outer space exists in plasma state. Also like stars, sun, cosmic nebula. I mean the highly charged state with hydrogen gas. What is cosmic nebula? I mean it's very high amount of hydrogen gas together that surrounded the stars in the space and the remains of a star after exploration. Okay. Also, we can see plasma state in lightning. You know the lightning? Okay. We can see plasma state in the space also in polar aurora. Polar aurora, some phenomenon that appears in the two poles, in the North Pole and the South Pole. You can search for it by using the internet to understand more what is aurora phenomena. But you have to know aurora phenomenon must be in plasma state or is existed in plasma state. I mean after the ionization of gases, after ionization of gases. Okay. Plasma state is very important in our daily life. So the most life application that we have to use in our daily life is the air conditioner. Plasma state improve the quality of air. How? Some air conditioners, and now I think most of air conditioners have the plasma state. What happened? These machines, the gases are passed through high electric field to convert their atoms into positively charged ions. So now we have positively charged ions in the air with negatively charged ions. What happened? There are many types of viruses and germs in the air. The negatively charged ions or the free negative charged ions attached and break down the viruses and germs in the air. So again, we give the air conditioner high electric field. This high electric field break down the atom or make the atom ionized, as we said up. Okay, electrons now become more freely. These electrons attach the germs and viruses in the room or in the air and break down them. That improve the quality of the air to become more pure, It's important life application for us. Search by using your remote control in your air conditioner to use plasma state. Okay? We finished our first lesson. See you later in the second lesson. Goodbye.